Graphene, the future of mining efficiency. What is graphene? Graphene, a material so extraordinary it's often called the wonder material of the 21st century. It's a one-atom thick sheet of carbon atoms arranged in a hexagonal lattice. Despite being incredibly thin, it's 200 times stronger than steel, more conductive than copper, and flexible enough to bend without breaking. These unique properties make graphene a game-changer across multiple industries. From electronics and energy storage to medical devices and transportation, graphene's potential seems limitless. But perhaps one of its most transformative applications is in mining, where strength, conductivity, and flexibility could revolutionize how we explore, extract, and process valuable resources. Mining is one of the world's most resource-intensive industries. It requires heavy machinery, large-scale exploration, and energy-intensive processing. But with graphene, many of these challenges could be addressed head-on. One of the most promising developments is the use of graphene in next-generation sensors. Companies like Zen Graphene Solutions and Haydale Graphene Industries are developing ultra-sensitive, graphene-based sensors capable of detecting mineral deposits deep underground. Unlike traditional sensors, which rely on broad scanning and indirect data, graphene sensors can pinpoint the exact location of valuable minerals. This precision cuts down on unnecessary drilling, reduces exploration costs, and minimizes environmental impact. Graphene also enhances the tools and equipment used for extraction. First Graphene is leading efforts to develop stronger, lighter, and more wear-resistant mining components using graphene-enhanced composites. These advanced materials increase the lifespan of mining tools, reduce equipment downtime, and speed up extraction processes. The result? Faster operations, lower costs, and fewer delays caused by equipment failure. Beyond tools, graphene's conductivity also plays a role in energy efficiency. Mining equipment generates enormous amounts of heat during drilling, crushing, and processing. Graphene's ability to dissipate heat more effectively could prevent overheating, reduce energy consumption, and extend the life of mining machinery. Flash joule heating, a new frontier for mining. While graphene is revolutionizing mining tools and sensors, the process of making graphene is just as transformative. Traditional production methods like chemical vapor deposition, CVD, were slow, expensive, and difficult to scale. But thanks to flash joule heating, FJH, a groundbreaking process developed by Rice University, large-scale, cost-effective production of graphene is finally within reach. Flash joule heating works by exposing carbon-based materials to an ultra-rapid burst of high voltage, converting them into high-quality graphene in seconds. This process requires no solvents, harsh chemicals, or extensive processing. What's more, it can convert nearly any carbon-rich material, including coal, bio-waste, and even old tires, into valuable graphene. But the impact of FJH doesn't stop at graphene production. MTM Critical Metals is now exploring how this process can be used directly in mining operations. Using FJH, MTM has developed a method to extract lithium from spodumene, one of the most important lithium-bearing ores used in batteries. Traditional lithium extraction methods require high heat, strong acids, and significant energy consumption. In contrast, FJH extracts lithium more efficiently, with fewer emissions, less energy use, and significantly lower costs. This same concept is being explored for other critical minerals like rare earth elements, copper, and nickel. Instead of relying on traditional smelting or chemical leaching, FJH could convert raw ore directly into a refined, usable form. Companies like Universal Matter are working to refine this process for large-scale mineral extraction, a move that could drastically cut down on the energy costs and emissions associated with metal production. The potential for FJH in mining is enormous. By processing ores directly at the mining site, companies could eliminate the need for costly off-site refining. Portable, on-site FJH units could extract key metals like lithium, copper, and nickel right from the source, creating a closed-loop system that reduces transportation, emissions, and environmental impact. Graphene's impact on mining efficiency. When it comes to mining, efficiency is the ultimate goal. From exploration to extraction and processing, every step requires time, labor, and energy. Graphene offers ways to improve each of these steps, making mining faster, cheaper, and more sustainable. 1. Smarter exploration with graphene sensors. Exploration is one of the most expensive and time-consuming parts of mining. It involves scanning vast areas for potential mineral deposits and conducting multiple rounds of drilling to confirm findings. But graphene sensors, like those developed by Zen Graphene Solutions, could change this process entirely. These sensors are ultra-sensitive, capable of detecting trace elements of minerals that would otherwise go unnoticed. By providing real-time data on mineral concentrations, graphene-based sensors can guide exploration teams with pinpoint accuracy. The result? Fewer exploratory drills, less wasted time, and lower exploration costs. 2. Faster, tougher extraction with graphene-enhanced tools. Once a deposit is located, the next challenge is extraction. Traditional mining tools like drill bits, cutting heads, and conveyor belts face constant wear and tear, but tools made with graphene-infused composites are stronger, more durable, and more resistant to abrasion. Companies like First Graphene are developing graphene-enhanced materials for high-impact mining environments, ensuring that mining tools last longer and require less frequent replacement. The increased strength of graphene-based components also allows for faster cutting and drilling, reducing extraction time. Since these tools require fewer replacements, the entire supply chain becomes more efficient, lowering maintenance costs and increasing operational uptime. 3. Energy-efficient processing with graphene conductivity. Processing raw minerals into usable metals requires crushing, grinding, and smelting, all energy-intensive steps that consume vast amounts of electricity. But graphene's conductivity offers a way to reduce this energy consumption. Graphene's ability to dissipate heat can prevent mining equipment from overheating, which lowers energy use and reduces the need for complex cooling systems. This is especially relevant for high-energy processes like crushing and grinding, where energy costs are significant. By integrating graphene into these processes, mining companies could see dramatic reductions in energy usage and operational costs. Graphene's potential in mining is enormous, but like any disruptive technology, it faces hurdles. Production used to be one of the biggest obstacles. Chemical vapor deposition, CVD, methods were too slow, expensive, and difficult to scale. But with flash Joule heating from Rice University, those challenges are rapidly being overcome. Flash Joule heating is already being adopted by companies like Universal Matter, which is developing large-scale production methods to supply graphene at a fraction of the cost of traditional methods. The ability to produce high-quality graphene from coal, biomass, or recycled materials could create a steady, sustainable supply of graphene for mining applications. Scaling this production to industrial levels is critical for mining. Without an affordable supply of graphene, it will be difficult for mining companies to fully adopt graphene-enhanced tools, sensors, and processing technologies. But with flash Joule heating on the rise, this problem may be solved sooner than expected. Another challenge is the commercialization of FJH for mineral extraction. While MTM Critical Metals has already demonstrated success in lithium extraction, more research is needed to prove the feasibility of extracting other critical minerals like copper, nickel, and rare earths. If successful, this process could revolutionize the entire mining sector, making ore refinement cheaper, faster, and more sustainable. The future of mining with graphene. The mining industry is on the edge of a technological breakthrough. With graphene-enhanced tools, smarter sensors, and on-site mineral extraction using flash Joule heating, mining operations could become more efficient, more sustainable, and far less resource-intensive. Gone are the days of guessing where mineral deposits are buried. With graphene-based sensors, exploration becomes precise and data-driven. Extraction no longer requires constant tool replacements, thanks to graphene's durability and wear resistance. And with flash Joule heating, companies like MTM Critical Metals are leading the way toward cleaner, greener extraction methods. Imagine a mining site with on-site portable flash Joule heating units capable of extracting lithium, nickel, or copper directly from raw ore. No smelting, no chemical leaching, and no shipping raw material to distant refineries. It's a vision that's already taking shape. Companies like Zen Graphene Solutions, First Graphene, Universal Matter, Haydale, and MTM Critical Metals are redefining the future of mining. Their innovations are driving the industry towards smarter, cleaner, and more efficient practices. This is more than just an evolution of mining. It's a complete reinvention of how resources are found, extracted, and processed. Graphene isn't just making mining better, it's making mining smarter, cleaner, and more sustainable. The future of mining isn't decades away, it's happening now. And at the heart of it all is graphene.